It's a real pleasure to have Sanjeev Gupta today with us, the second time. This is following the quite an interesting webinar, the first one presented by Sanjeev, and the responders that we have got of an interest to learn more and to have the ability to probe and to go deeper into the significant message that Sanjeev said in the previous one. There's no real need to introduce Sanjeev, but I'll say it nevertheless, because Sanjeev is a true leader of TOC in logistics with over 30 years of experience. He has a very deep understanding, knowledge, and incredible experience in the areas of flow, production, supply chain, project, and extremely important in the multi-project environment. So I think that the knowledge and the insights that Sanjeev have developed over the years are extremely important, and we would like to probe into that. So, to you, Sanjeev.
Thank you, Odette. Thank you, Elena. Thank you, Nereus. And good morning, good afternoon, good evening, wherever in the world you are. This webinar is, as Odette mentioned, it's building upon the materials I presented the last time. And the specific topic we want to dive a little bit deeper into is buffers. The structure is simple, which is we know that buffers are an important part of all the TOC logistical solutions. And for me, that means really planning and scheduling. And for me, what also that means is that it's not about TOC. You know, if you want good plans and good schedules, you need buffers, right? You cannot have enterprise-wide or system-wide planning and scheduling without buffers, because of the simple fact that variability and uncertainty exists. And if you don't have buffers, you are on the one hand fooling yourself. On the other hand, you are creating most likely interactive constraints somewhere in the process, which will jeopardize your performance. The second, then I'll take it from there and I will talk about what is the traditional view of critical chain project management and the buffers. And I think, you know, personally, what I believe is that the traditional view of CCPM buffers has done more harm to CCPM than bringing value to it. More harm in the form of, in the meaning of, you know, how widely it has been adopted. Then I will talk about the reality of projects, which is a point of view that I presented the last time, in terms of what happens in projects, where does value come from through better planning and scheduling or through the TOC planning and scheduling. And from that, I will derive what is my view and perspective on CCPM buffers. Right, so if we look at the buffers, and this is classification that, you know, I presented at the TOC ICO conference. It's not set in stone, but this is my classification, that buffers kind of exist for three different purposes. Availability, which is you have customer demand that cannot be predicted. So you need some buffer of whatever it is. And is really a stock buffer, whether sometimes it can be capacity that you are renting out to your customers, sometimes it is goods that you are selling to your customers, but that is the availability buffer. The commitment buffer is around that in the future, I have made some commitment for the future to a customer, and I want to protect the commitment. So that is the purpose of the commitment buffers. Flexibility buffers are all internal. So this is saying that you create some plan but the plan is going to change because of variability. So you need flexibility in execution to respond to those changes. And that is what I mean by the flexibility buffers. So example, I already talked about it, that the inventory buffers at the point of sale in a retail environment is definitely an availability buffer. We cannot predict when the customer will walk in or what item they will want. So we need to carry the buffer there to have the goods available to them instantly. An example of a flexibility buffer is, again, it's an inventory buffer, but is not something that is for availability. It is giving you scheduling flexibility. For example, when you have a V plant, the inventory that you carry at the base of the V is a flexibility buffer, because you can then divert it along one path of the V or the other path of the V, and you can modify your schedules depending on what demand is coming in or how the demand is changing. And so that is what I mean by flexibility buffer. The commitment buffer is the shipping buffer in production. And so you want to make a commitment that you want to be able to keep. So the total time it takes you to manufacture a product or a part might be a day or 2 days or 3 days, but you put enough of a buffer, maybe a week or 2 weeks, so that you can make sure that when you have promised a due date to the customer, you can meet the due date. And needless to say, the buffers can come in all shapes and sizes, time, capacity, materials, etc. Right. So in this webinar, we are really addressing the issue of time buffers in critical chain project management. So that is what I will restrict the rest of this webinar to. The orthodox or the traditional view is that buffers in projects, the time buffers, are for protecting commitments. And the benefits in terms of being able to deliver projects faster or being able to do work more efficiently comes from optimizing buffers. And there are different ways that it has been said by various people as to how you get these benefits. One is simple aggregation. You have task level buffers. At task level, you need bigger buffers than if you aggregate the buffers at the project level. So there is going to be benefit of cycle time when you do that. And there is also going to be benefit of effort by eliminating student syndrome and Parkinson's law. The second part, which has been brought forth by some people, is that exposing buffers. You make the buffers visible, and when those buffers are visible, they are less likely to be wasted through, again, behavioral issues like student syndrome, error reporting, Parkinson's law. There is also the idea that buffer management gives you some benefit, which is by putting your resources on the right tasks, by giving the right priorities for resources as well as for management, and also providing advance warning so that you can look forward into the future and make some course corrections before the fact rather than after the fact. So that also leads to some benefit. And finally, buffer diagnostics, which is once you have executed for a certain period of time, you can analyze the causes of buffer consumption and identify improvement areas. Right, so this is the orthodox view. Now, if we look at it in terms of what it kind of questions it raises, the moment we present critical chain from this point of view is, hey, if we are going to aggregate buffers, take out buffers from the task into the project, then different tasks have different kind of variability. Now, there are some tasks that are absolutely fixed. There are some tasks that are variable, even variability wise. Some tasks have less variability. Some tasks have more variability. So should we be reducing the task durations differently for different tasks and aggregating that into buffer? And this is again, the whole process of ABP, HP, that rat hole that people go down in terms of coming up with estimates, right? And the reason I call it a rat hole is, you are predicting a task of, you might have done similar tasks before, but you have not done this task before. So it's all estimates. Now, applying these statistical tools on top of estimates, guesstimates, to me is a rat hole. Applying statistics on top of repeating patterns of variability is good, but applying statistics on top of these estimates about the future, I don't know how much sense it makes. Immediately, that also leads to, hey, should we have different buffer sizes for different projects? We have the same set of resources that are doing, sometimes working on purely researcher type of projects, and sometimes they're working in latter stage, which is product development, where uncertainty is lower. Sure, but should we have more buffers for research projects and less buffers for development projects? Right, so this is a question that comes up. And a side question that has been raised a few times, I think is a good question, which is the project buffer more important or the feeding buffer more important? On execution, I think the main question that comes up is, how should you set the red, yellow, and green curves, the slopes and the regions? When should a project turn red? When should a project turn yellow? When should a project remain green? That is the execution question. And what it also leads to is, if we buy into this aggregation idea, that it does create some buying challenges. When CCPM is first implemented, the buying challenges around, you're telling people, hey, you have got these buffers hidden in your tasks. We need to take them out. So it's a little bit accusatory, which is, you got these hidden buffers, and now you're to get into explanations. No, we really are not accusing you. And the person is saying, but I'm working hard all the time, and how can there be any hidden buffers? And then you tell them, yes, you are working hard, but at the task, so there's a whole lot of complication that comes around the buy-in process when you talk about taking buffers out of tasks and putting them into projects. And for ongoing usage of critical chain project management, this is what I have seen quite a few times, that you go and do the implementation the first time around, second time around, third time around. When you plan the project, okay, you overcome the initial difficulty of buy-in, then things are okay. But then at some point, people start getting smarter. They start recognizing the pattern. And they know that if their task will be shrunk by 50%, then let me just double my estimate. Right? So that is the pattern that you fall into. So what happens is, even in successful implementations, if you are managing to finish a project in, let's say, 18 weeks, over time, the duration expands because people start inflating the estimates in response to what they have observed in terms of cutting the durations. So these are the questions and challenges that I think are important questions, that are practical questions. Now, instead of answering the questions directly, I want to first make one point, which is the benefits of focus and finish are much bigger than the benefits of buffer optimization. So this view of buffers is about optimizing buffers. And theoretically, I cannot argue with these points. In theory, they are right. I don't know how practical some of these elements are, like buffer diagnostics, but in theory, yes. But in reality, the benefits of focus and finish far outweigh the benefits of buffer optimization. And this is what I had presented last time, but I will recap it. Right? What I mean by focus and finish. So we'll take a very simple case, very trite case, that you have 3 projects. Each project goes through 3 phases. You have a blue phase, followed by a red phase, followed by a golden phase. And if I put 3 blue resources on the blue phase, then that blue phase can get done in 6 weeks. If I put 9 red resources on the red phase, it can get done in 10 weeks. If I put 6 golden resources on the golden phase, it can get done in 4 weeks. And I have 3 such projects to do. And I have only 3 blue, 9 red, and 6 red resources. So now when we come to planning and scheduling, whether it's planning or actually in execution, the day-to-day scheduling. So one mode is to say, if I put all these 3 people on this one blue task, they are not busy all the time. So it is not efficient. And in fact, if I put these 3 resources, 1 resource on each of these tasks, then instead of taking 6 plus 6 plus 6, which is 18 weeks, I can finish the 3 tasks in parallel in 15 weeks. So I am more efficient. My resources are much better utilized. They are not sitting idle. The ditto for the red, that instead of putting 9 resources on one task and finishing it in 10 weeks, I put 3 resources on one red, 3 resources on the second, 3 on the third one, and instead of taking 10 plus 10 plus 10, 30 weeks, I finish it in 25 weeks. And for the golden also, instead of 4 plus 4 plus 4, by putting all 6 resources on one task at a time, if I spread these 6 resources as 2 plus 2 plus 2, then I can finish all the 3 golden tasks in parallel in 10 weeks. And so this is the way people tend to think before critical chain project management is introduced, or this is the way when people tend to think when they have to make all these local decisions, because you don't have a plan or a schedule that you can really follow. So the only thing you can rely on is local optimization. Right? So when you think like this, you'll finish the 3 projects in 50 weeks. But when you think, focus, and finish, you finish the first project in much less time. So instead of the cycle time being 50 weeks, you are able to achieve it in 20 weeks. Right? So look at the duration in cycle time we got through focus and finish versus the duration in cycle time we would have gotten through the traditional way of saying, let's take half of your estimate, throw away half of it, put half of it into the buffer, right? So then this 50 weeks would have become 25 plus 12 and a half, 37 and a half weeks. But now in this case, we are saying you can actually finish it in 20 weeks, the cycle time. And you can start the second project based on the red resource somewhere here, which is somewhere 10 weeks later. And you can finish it approximately 10 weeks later. So in 30 weeks, you will finish 2 projects. In 40 weeks, you will finish 3 projects. And the other way of saying it is, given another 10 weeks, I can do 1 more project, right? So this is the productivity gain and the cycle time gain you are getting when you are adopting focus and finish. The point, there's one side note, it's not the main point, but a side note I do want to make is that a lot of focus on critical chain is about individual multitasking. Talking about the setup and set down cost, right? Which assumes that when I switch between tasks, I am less efficient. To me, that is an extreme case that might happen, might not happen. But in this case, what I have assumed is that when we are spreading resources thin, we are actually more efficient at a task level. Unlike in multitasking, when we switch between tasks, we are less efficient. Over here, I have assumed that at a task level, you are more efficient when you spread your resources thin. And the point here is that despite being more efficient at the task level, at a project level or at a multi-project level, you are less efficient. Right, so this is the benefit of focus and finish. Now, how this focus and finish versus spreading thin actually happens, I think it is also a slide worth revisiting. Right, so one is simple. You have a team sizing, which is the case that we discussed. Instead of having 8 people dedicated to one project, 8 red, 8 yellow, 8 blue, you split them into 2 teams and put 4 people in each project. Right? So this is the example that we just saw. The other example of spreading thin is synchronization. One department is giving priority to one project, another department is giving priority to a different project. So the red department thinks project 1 is more important. The yellow department thinks this project number 2 is more important. As a result, you cannot do the integration of any of those projects until both yellow and red are finished. So projects end up taking longer, right? So and you get a cycle time reduction. So these slides are available, so I don't want to go through the slides in detail because I do want to open up, have enough time for questions and answers. The slides are pretty self-explanatory. Right? There is another example where interactive work happens, where you have, for example, where you're doing outfitting in a ship manufacturing case, right? So you have people who are laying pipes, people who are laying cables, and they need to work together because how I lay out the pipes affects how I lay out the cables and so on, right? So if I work together, I can get the task done in 5 days, but if I work separately, then I get it done in 12 days, right? So this is another example where taking a set of resources that need to work closely together, focusing them on one set of tasks yields better results. And there is focus and finish at the management level, which is in a project, the work is not flowing from left to right. The work is from left. Then when you have a problem or a decision to be made, it flows to a manager or an expert who resolves the issue, comes down, and the project starts moving again. And the challenge here is that this is like a help desk system or like a bank teller example, where you need instantaneous availability of this manager to solve the problems. And if this instantaneous availability is affected, then you end up taking, your cycle time goes up exponentially. So in this case, being able to take managers and focus them on fewer projects at a time yields better results. Okay, so this is just the detailed explanation of how focus and finish is achieved in projects. Now, if we agree with this view, okay, one more point I want to make, that why focus and finish yields such better results. Resources are spread thin in projects. Every task ends up taking much longer, and the longer a task takes, the longer the downstream waiting time, right? And this is very different from production, where the ratio of touch time to lead time in production is lower, in project is very high. So every time you have a task taking longer, it is directly affecting the lead time of the project. Unlike in production, if some task takes longer, it doesn't really affect the total lead time. In projects, it does. And also what happens is when resources are spread thin, in this case, so all the blue tasks are finishing at the same time, which means now the red resource is suddenly getting a bow wave of work. And when red task finish, then the golden resources get a bow wave of work. Right? So you get these peaks and valleys, which also lead to inefficiencies. So if you agree with this point of view, that focus and finish is the real source of gains in projects, some of these points that I made earlier assume even more significance, which is benefits of focus and finish far outweigh the benefits of buffer optimization. Right? We kind of took a trite example, at least to bring out from my perspective what the benefit is. Right? Even if you look at a lot of implementations, the typical number of projects that are going on before you enter an implementation versus the number of projects that you actually allow the client to keep executing, it's not a reduction of 10-20%. Normally in our implementations, if client has 20 projects going on, when we start the implementation, we freeze not about 25%, we freeze about 60, 70, 80% of the projects. So that is the amount of freezing we end up doing, right? And if you reduce the number of projects by a factor of 5, then your lead time goes down by a factor of 5 or more. So if I have 10 projects going on, that means the queue in front of every resource, if the resources are spread thin, is, let's say, 10 projects. Versus if I have 2 projects going on, then the queue is going to be cut down by a factor of 5. And when you cut down the queue by a factor of 5, you automatically reduce the lead time or the cycle time of the project by about a factor of 5. On top of that, if you add other effects of reducing the queue, which is now resources are more focused, you finish every task faster, and the downstream resources can start working on a task faster. That also adds to the benefit. So point I'm making is the benefit from reducing the number of projects in execution by doing more focus and finish is going to be out of the order of magnitude of 50%, 60%, 70% in terms of cycle time, versus when you do buffer optimization, then the maximum benefit you're going to get is about 25% reduction in cycle time. The second is that if I look at a project plan, even most typical projects along a chain of tasks, how many tasks are you going to have? You're going to have 5 tasks, 10 tasks, 20 tasks, maybe 30 tasks in extreme cases, right? So this 20, 30 tasks is not enough to take advantage of aggregation anyway, right? You can aggregate in supply chain, you can get benefits from aggregation in supply chain because the numbers you are talking about are much larger. But when you have a small number, then I'm not sure that you can get enough aggregation in a predictable way to say benefits come from aggregation.
Are you speaking only about the number of tasks, or are you also speaking about the duration?
Just the number of tasks.
Just number of tasks. And let's say just if there are 20 tasks that are pretty long, so it is the same as there would be 20 tasks that are short. Either way,
Yes.
You're saying that the fact that there are only 20 tasks, it's not enough to take advantage of aggregation.
Thank you. That is good clarity. Yes, that is what I'm saying.
Mm-hmm.
Right. And what I discussed last time was that I can calculate priorities and warning signals without buffers too, right? So the benefit of buffer lies somewhere else, not in producing the benefits that we talked about on this slide here. And the benefits of buffer lie somewhere else, and that is what I want to spend some time on. So if I look at a project, if I don't have a buffer in the project, so this is a very simple project where you have longest chain, which is about 7 tasks, and each task is 3 weeks long. So my critical chain is 21 weeks long, or critical path. Then you have 2 feeding chains, one feeding chain at the top and one feeding chain at the bottom. The top feeding chain is 9 weeks long. And if you look at this plan, what you will see is the feeding chain at the top is finishing 3 weeks before it is the project due date, and there is 0 slack here. Between the feeding chain and the critical chain, there is 0 slack if I plan the project like this without a buffer. If I add a project buffer to it, interestingly, what it does is, so let's say we add a project buffer, and we did it some arbitrary way. We said instead of 3 weeks, 3 weeks, 3 weeks, we will take 1 week arbitrarily from each task. It's just arbitrary. It doesn't, we are not going to go into any statistical calculations. Arbitrarily, we take out 1 week from each task and put it into the buffer. Now, interestingly, what it does is not only does it create a project buffer of 7 weeks, but the more important thing it is doing is if I look at this feeder chain, the feeder chain has moved back by 7 weeks compared to when it is needed on the critical chain. Right? So the difference between feeding chain here on the top box versus the feeding chain here, this difference is the benefit. of having a project buffer. I did not introduce a feeding buffer into this yet, right? I'm just introducing a project buffer. But by putting a project buffer like this, I have actually introduced slack on the feeding chain. Right? And this is the benefit, because what it now allows me to do is it makes the critical chain more stable, which means everywhere I can do focus and finish. If I do not have this slack, then sometimes the original critical chain is the critical chain, and sometimes the feeding chain becomes the red chain because it might be going a little bit slower. And this flip-flopping is the opposite of focus and finish. So when you have to shift between critical chain and non-critical chain, your priorities often, that means you are not focusing and finishing anything. It's the opposite of focus and finish. But by putting the project buffer in, I am introducing a slack after the feeding chain before it is needed on the critical chain. And this slack allows me to keep the critical chain stable. Right? So this is the benefit that I see from the time buffer aspect in projects. And if I can add feeding buffer on top of it, it creates more stability, right? So project buffer and feeding buffer, in my mind, or in my experience, are fulfilling the same purpose, give or take, which is they are creating more stability in terms of what chain is critical and which one is not. And hence, they are allowing the organization to operate more in a focus and finish way. So, given this is how I would answer the questions that I had listed down before. Do I need a different duration reduction for different tasks? Not really. Unless there is an exception where there is some task where I really don't want to reduce the duration, and I will come to it what type of tasks they are. But all that matters here is that my project buffer is 7 weeks long. It didn't matter whether task number 1 got reduced by 1 week and task number 3 got reduced by 2 weeks. That didn't matter. All that mattered is my project buffer is 7 weeks long, right? Where you might have this distinction between different tasks is if you have a task which is done by an external vendor, right? So the external vendor probably is not going to operate to a flexible schedule. So you want to give, if you have an external task on your project where for whatever reason, the commitment that your supplier is giving you is a fixed lead time commitment. So you say, okay, for those tasks, we will not do any reduction, and it is what it is. But beyond that, I would not get more sophisticated in terms of AVP, HP estimates, and saying some tasks have less variability, some tasks have more variability. The same logic carries forward in terms of different sizes of buffer for different projects. And it really doesn't matter, because what we are talking about is our project, there needs to be enough slack between the feeding chain and the critical chain. Which buffers are more important? Project buffer gives you more slack by definition, because in this particular case that I am looking at, the project buffer is giving me generating a slack of 7 weeks. If I applied the logic here on the feeding chain, the amount of slack generated will be less because the length of the feeding chain is smaller. But feeding buffers are also important. But if I have to choose between one or the other, I would say project buffers are more important. In execution, red, yellow, green, right? So in practical terms, I have not been able to find any benefit of a yellow, because it's not as if when you see the yellow project, then you start preparing, watching it more closely, and then preparing for buffer recovery just in case it goes into red. So color is actually kind of a wasted color in the context of projects. And setting as to when a project turns from green to red, it is subjective. And what I mean by subjective is the main purpose here is to cause people not to panic. The meaning of going from, so between green and red, the color that is more important is green, not red, right? Because the main thing is I want people to stay focused and finish what they are working on instead of reacting to, hey, something else became red and let me suddenly switch all my priorities into red. So between red and green, the more important color is green, that allows people at an individual level, at a worker level, to focus and finish whatever they have started. Right? In terms of buffer recovery, if you are going to find that your project is going to be a little bit late, right? It doesn't matter if it's red or green. If you can do some buffer recovery, you should do it. And the mechanism for buffer recovery is not coming from the time buffer. The mechanism of buffer recovery, or the main way you do buffer recovery, is through resource buffers. So if I go back to this original picture that I had in terms of the roles of the buffers, so the real commitment buffer in the project is the extra resources, not the extra time. The time buffer is more of a flexibility buffer in projects, is not the commitment buffer. Right? If you want your project to be able to recover when it is falling behind, the way to do it is to spend extra money, spend extra resources. The extra resources that you should have in the project is the real commitment buffer that allows you to meet your commitments. The time buffer in the projects, the project buffer and the feeding buffer, the time buffer in the project is not a commitment buffer. It doesn't protect your commitments as much as it gives you flexibility of schedules. So the time buffer in the projects is more like a flexibility buffer. The money, the resources are more like commitment buffers in projects.
I see how the flexibility buffer serves the business objective to be reliable. What is the business problem, corporate problem, that is fixed by the availability buffer and commitment buffer? Can you clarify?
Yes. So actually, I'm saying somewhat the opposite. The availability buffer and commitment buffers are protecting your throughput. Because when you have a customer who walks into a store and they don't get the item they want, you lose throughput. So availability buffer is the business objective is throughput. Commitment buffer is not as much as throughput, but customer satisfaction. You made a commitment to the customer, you want to meet that commitment. And sometimes it is throughput also, because if your project doesn't get done by a certain date, then you can lose throughput. So commitment buffer and availability buffers, the business objective they are fulfilling is throughput. The flexibility buffer is an operational thing. The need it is satisfying is giving flexibility to operations to modify the schedules in response to real-time conditions.
Okay, thank you. So let's continue.
Yes. Right. And the buy-in, I think from me, the buy-in always starts with not how much buffer you need. The buy-in always starts with what is the market allowing us in terms of timelines of our projects. Timelines in most cases, in almost every case, are dictated by a market need, not by what you think is feasible internally. In today's world, you have to finish the projects when either the market or the customer wants you to finish the project. So timelines are dictated by the market. And project buffer can be some way, again, is a rule of thumb. You can modify this number. This number is not set in stone, but the project buffer is some significant percentage of the total timeline. This buy-in is true when you implement critical chain the first time around, or you are using critical chain on an ongoing basis. Right? So the sensitivity in the organization that you need all the time is, guys, how long do we take to do a project? It's not about what we think is possible. It's about what the market is allowing us. And now let's find a way to get the project done in that much time. Right, so this is how I answer the questions that I had listed in the beginning. But if there are additional questions, I can answer those too. Before I do that, I want to repeat one point, because, and this point is important for me to repeat, is I see a lot of value in the agile way of managing projects, or at least the software development, and defining short sprints, etc. But the part that I have seen that creates havoc in agile and sprints, the part that is very destructive, is time boxing. Right? So what happens with time boxing is you say that no matter what, every sprint is going to take 4 weeks or 6 weeks. And in that time pressure, what happens is you leave features and functionality half done, or you cause people to panic to meet the deadline. And you cause resources to start spreading thin, because instead of focusing on one feature at a time, and you say, in this timeline, we've got to finish 5 features, so let me also take some resource that is sitting idle and put that on feature number 3, and that ends up spreading the resources thin, and ultimately it hurts everyone, right? So, and the reason it belongs to this webinar is this idea of focus and finish. And the focus and finish is the way to get benefits in projects. And if you choose to implement Agile instead of critical chain project management, it's okay. But what is not okay is time boxing. Now, with that, I want to open it up for questions.
How can the throughput go up when you take the buffer? It was coming back to the previous discussion about the buffers.
So that is, Edmund, so it's a different topic of discussion, right? But I'll give you a 1-sentence reply, but you might want to watch my TOC ICO presentation from 3 years ago. But the main point is simple, that if you have variability and uncertainties in an environment, and if you don't have buffers, then you end up creating interactive constraints. And when you have interactive constraints, your throughput goes down. So it looks like buffers are taking away from available capacity. In fact, they're adding to available capacity by reducing the interactive constraints. Next one.
Market usually provides less time than it's necessary, because owners, operators approached IPC late from the beginning. I don't know what IPC stands for.
Probably EPC. EPC is for EPC vendors, yeah.
Yeah. And then project managers are given ISD that 8 unreasonable, granted with traditional task level buffers.
Right. So I would put it more, instead of an answer, I'll put it more as an assertion. So if my mode of operation is spreading thin, then the timelines that are given to me in projects, in EPC projects, they seem infeasible. But if I change my mode to focus and finish, then those timelines are imminently feasible. And case in point is power plants. Everywhere in the world, it takes 6-7 years to create a thermal power plant. If you go to China, a thermal power plant gets built in about 2 years. So for everyone else in the world, 7 years, going down from 7 to 5 is very aggressive and feasible. But in China, you do it repeatedly in 2 years.
Do you have a suggestion for the size of the green versus red sizes? For example, 2/3 green to 1/3 red?
Yeah, so it's a slope, a slope that you need to define. So normally our implementation teams, they start the clients with saying, okay, the project is starting, don't turn it red on the first day. So maybe you allow 10% buffer consumption before it turns red in the beginning of the project. Towards the end of the project, you don't want to create panic. If your project is going to be delivered on time, then it is green. So maybe you allow 95% of the buffer to be consumed towards the end of the project before it turns red. And that gives us good starting point, which gets modified by the clients based on their comfort level.
Project buffer goal, then, it is not to reduce the project due date and maybe achieving a competitive advantage, but rather it is to add required flexibility to be able to comply with any committed due date and to be reliable on it. Is it true?
Yeah, so I would say the commitment buffer again is not going to come from this time buffer, the project buffer. If you are falling behind in a project, the way to recover is going to be to apply extra money or resources to the project. The commitment, reliability of commitment comes from resources, but the internal flexibility of saying that I was supposed to start working on a feeding chain today or a task today, but I can delay this task for a week or two because my critical chain is still not finished. But that is what I mean by the flexibility. So that is the purpose of the time buffer in project. Giving this scheduling flexibility of not doing the task exactly when you thought it should be done when you created the plan. That is the flexibility of scheduling. The meeting of commitments will still come from applying extra resources or extra money to do the project. This is an important point because I think what has not been talked about in projects often is this resource buffer idea, right? So a lot of focus has been on the time buffer, and even the resource buffer that is talked about by Ellie in critical chain is really a time buffer. It talks about resources having some time before they are committed to a project. So the idea of capacity buffer in projects, when I say resource buffer, is capacity buffer. The idea of capacity buffer is probably an underappreciated idea or not even part of the body of knowledge. Right? Having capacity buffers in projects is extremely important. Similarly, having a buffer of money is also important. And I've talked about this buffer of money idea in the TOC handbook in chapter 4. Right? How do you set aside, how do you decide this, how much money should be set aside, and how do you use it both in a single project environment and in a multi-project environment? I've talked about it in chapter 4. But having this money and capacity buffers is very important in projects if meeting commitments is very important to you.
TOC-ICO dictionary defines DBR as a buffer management, defines in the DBR as a buffer management function as first, prioritize, B, expedite, and C, escalate system parameters. D, target local improvements. Is there similar like things in CCPM buffers?
Yeah, you can use buffer management for the same purposes in CCPM also, yes, right? But the point where I depart from TOC ICO is that that is not the only way to derive priorities. I can derive priorities without buffers. I can derive areas for improvement without buffers. So buffer management is not the only scheduling algorithm or the calculation algorithm that will give you those answers, those calculations. I can do it without buffers. But whether in CCPM or DBR, I think we can agree with whatever is in TOC ICO dictionary, which is, buffer management does give you those outputs.
That buffer of money are contingencies and management reserves. Is it true?
It is. But I think there is a slight difference in the way you use it. And it also has an impact on how do you calculate project cost and hold people accountable for project cost, especially when you go from single to multi-project environment. Right? So people know that you need contingency, right? And this is what they use contingency for. But the way it is used, the way it is financially accounted for, the way it is set aside, that is where, what I have put down in the chapter 4, it might be relevant.
There was a resource buffer term to describe a signal to the next resource to be ready for the next task. So what you mean, because the question is, are these resource buffers still used?
I don't care, because with the software technology that is there, so that is a time signal, right? And that is what I meant. The way LE used resource buffer in defining critical chain is not really a resource buffer, it's a time buffer for the resource signals, right? And I don't really need that with the technologies that are there, because I can always tell resources when they should get ready without having an explicit buffer in the plan for that. So I don't know if the resource buffer should be used or not, but I think the more important point for me is that this idea of protective capacity and capacity buffer is really vital in projects in my mind, which has not been written about, talked about, or it has been underappreciated.
You say that timeline is determined by the client. This does not avoid the problem of buy-in with your resources. If it is decided by the management edict and they feel it's too short, would they not be demotivated by this?
The point is that if you want the organization to have a North Star, then you always need to start with what the customer and the market wants. And the more the people understand in the organization what the market and the customers want, the better it is. Then you are not fighting with each other, you are fighting together to overcome an obstacle.
You were saying that focus and finish gives more benefit rather than the buffers in CCPM.
Yeah.
And so actually, just what you're saying, to gain this benefit or to gain the benefit in project management, staggering is enough, because just what in effect focus and finish is in effect staggering, pipelining.
Yes. So yes and no, in the sense that without staggering, you will never achieve focus and finish. So staggering is necessary for focus and finish.
Yeah, right? Exactly. This is what I wanted to say, that staggering is focus and finish. So if you do not apply focus and finish, then you cannot do proper staggering.
That is correct. Yeah.
Mm-hmm. So then the question may be asked, where is tier C? Where is CCPM? Can I continue like thinking loud? If we stagger according to the duration of the project, which is determined by critical chain, maybe according to is the wrong word, but critical, if the critical chain somehow is there, then it is sort of about tier C. But if I put all my resources and I don't spread them thin, and by this I will probably eliminate resource contention inside a single project, and I will probably eliminate resource contention between the projects, then it becomes critical path. And actually, you're presenting that critical path / critical chain.
Yes.
Then the question is, and that's not challenging. I'm just asking because just, well, I expect that they are made that. Then where is CCPM or where is TOC?
Very good. So yes. So I think so. Just to build on what you were saying, so I think you were saying the same thing as I was saying, but to build upon that, what we should strive for when we are creating a project plan for a single project in a multi-project environment is we achieve the duration that is dictated by the critical path. That is how we should think about resourcing a project.
And again, critical path, you said, duration that is dictated by critical path. Is that correct?
Yes, we should try to achieve that duration when we do the project plan in critical chain. Right? Which means having enough resources so that really you don't have resource contention in a project. But if you do have resource contention inside a project, then you should do staggering within the project of different legs of the project. Right? So the logic you should still use to resolve resource contention in a project at the planning time is the staggering logic. Right? So in this particular case, all these three legs could be part of one project instead of being three different projects. Right? So staggering is the way to handle resource contentions, not a detailed task by task schedule.
Okay, excellent. Do you need buffer management? Because you said the role of the project buffer, the main role is actually to provide for the slack for the feeding chain.
Yeah.
Then my question was then, do you need buffer management anyway?
So we do need some calculation of priorities, of project status, of being able to provide advance warning. Whether that calculation is based on by looking at the buffer versus the chain or using a different calculation, to me it doesn't matter, but you need a calculation.
Yeah, which right now supports that you do not need buffers for that. You can, and we discussed this last time as well, that you can use just a very simple calculation that you have been using actually. So you don't need the buffer. Then the buffer management would be needed for what?
Then you don't need buffer management, right? But I think you do need buffer for the slack, right? So if you're going to use it for the slack, you might as well use it for calculating all those things that we talked about, right? So but apart from that, you don't buffer management as in buffer calculations. Like you can do it using buffers or you can use an alternative way.
Okay. But if you do not need the buffer for buffer management, and if generally we say that the buffer is a mechanism, is a managerial mechanism in TOC, so then it might make sense to use any other word but not buffer for what you're putting at the end of the critical chain in this sense. Is this correct? I'm not suggesting that.
No, I'm agreeing with you.
Okay.
I'm agreeing with you.
So I think that's it for today. Thank you, Sanjeev.
Yeah, and thank you everyone for attending. Bye.